Okay, so slope is the steepness of a line. Okay, the steeper the line, the larger the number. Okay. If you move up in this direction, you have a positive slope. If you move down in this direction, you have a negative slope. And slope is represented in a couple of ways. You can have rise over run. You can have the change in y over the change in x. And so in math, this symbol means change. It's a delta, Greek letter. I know it looks like a triangle, but it's not a triangle. It's a Greek letter delta. Okay, or you can have the formula for slope, which is y2 minus y1 over x2 minus x1. Okay.
Can it be put the...
You could do y1 minus y2 x1 over x2. That you just, if you remember 2 minus 1, that's, and then it doesn't matter which points are 1s and which points are 2s.
Okay.
Does that help? Just the only thing you can't do is you can't do 2 minus 1 up top and then 1 minus 2 on the bottom.
No, it has to
They
be...
have to be in the same order. The first point, whatever point you pick, minus the other point.
So, because I had this class...
And you learned it the other way?
y1 is y2.
That's fine too.
It doesn't make a difference?
No, as long as they both go in the same order. Whichever one, if you put 2's first, then both the x and the y 2's have to be first. If you put the 1's first, then they both have to, it doesn't matter which, as long as they're the same. Does that help? Okay. Now, when you've got a graph, you don't have to do a bunch of calculating to find the slope. Yeah, it's true. Step 1 is to find any point on the line. Okay, now a point on the line is where it goes through the crosshairs perfectly. We have this one here. And then, yeah, it's kind of close on that. We'll just go ahead and say 3, 3. So you find 2 points. That's step 2, find the second point. Okay. Now you pretend that each of these points is a house, like one is your house and one is your friend's house. And then the lines going horizontally and vertically are roads. And you can't cut through this way because you'd be walking through people's houses and yards. You have to take the roads. Okay. I usually say to start at the left. Whoops, step 3. Because if you start at the left, you'll have to go up or down to get to the next point first. And up tells you positive slope, and down tells you negative slope. And then you always move to the right. And then the up and down is your positive and negative, and you don't have to worry about which is which. So I start here. So start. And I'm going to take these roads here to get from one point to the next. I'm going to take the main road. And I'm going to go 1, 2, 3, 4 up. And then I'm going to go 1, 2, 3 over.
So always up and over?
Yeah, or down and over.
Yeah.
If you always start on the left, it'll work that way. left, this is your left. Okay, if you always start on the left, it'll work that way that if you go up, if you start on the right, it's backwards. But if you're on the left and then move to the right, up is positive, down is negative, and then you don't have to, it's very easy to remember which is which that way. And you just move in the same direction you would read a page. So that's easier to remember which way to move to. So you're going to go up 4 over 3, and then so you move over. Up 4 over 3. So my slope is 4/3. And then if I had to go down 4 and then over 3, it would have been negative 4/3. So I'm going to find any point. Here's one. And I'll find any other point. And I'm actually going to find a point much further away than I need to, just to show what happens if you count too many spaces. Okay, so I'm going to count these, and I'm going to go from here to here. Whoops. What on earth just happened? Got stuck. Like that. So I'm going to go 1, 2, 3, 4, 5, 6. And then 1, 2, 3. Uh-huh. So I went down 6, so it's negative, and then I went over 3, and that's when I realized that, oh, I went too far. Because 6 divides by 3, right? Negative 2. Yeah, I could have gone down 2 over 1. See, here was a point right here. But I just didn't. You can pick any 2 points, and if there's a bunch of points along the way in between the 2 points you pick, that's okay. You'll just get a fraction that's reducible. So maybe you got 6 over 4, you'd make it 3 over 2. Divide it, yeah. Yeah, dividing. But if it's, why are you doing this? Let's say hypothetical. I got 6 over 4 like that. 6 doesn't divide by 4, but they both divide by 2. So I would reduce it. Okay, now here, okay, whoops. I can't count anything up and down, right? So I go up 0 and over a bazillion. It's going to be 0 over a bazillion, and that's going to be 0. Here I go up a bazillion, and I go over 0, and that's undefined. So if you have a flat line, slope equals 0. If you have an up and down line, or, you know, if I use the technical terms, horizontal versus vertical, but up and down, slope is undefined. Okay, if we have a positive slope, it goes this way. If we have a negative slope, it goes this way. A 0 slope is flat or horizontal, and an undefined slope is straight up and down. What on earth? If we're given the coordinates, not a picture, that's when we'll use that formula for slope. Or the other way around, it doesn't matter. You just have to pick which ones do you want to be the ones and which ones do you want to be the twos. I usually go in order because that makes sense to me. But you don't have to. So x1, y1, x2, y2. Okay. So I'm going to plug in y2 is 4, minus y1, which is 2. x2 is 0, minus x1, which is negative 1. And anytime you have a double negative, it's a positive. See, it's a happy person. Do you guys see the little happy person? And happy people are positive. So I'll have 4 minus 2 over 0 plus 1, which is 2 over 1, which is 2. And you can do it in less steps than that. I just wrote every single thing down. So look at number 2. We have negative 2, 5, and 1, negative 7. Name one, ones and 1, 2s, it doesn't matter which. Plug them in. I've got 5 minus negative 7. And I've got negative 2 minus 1. 5 minus negative 7 is the same thing as 5 plus 7. So I have 12 over negative 3, and those divide evenly, so I have a negative 4. Yes? 2 minus, no, because this is an x and this is a y, so the y's go together and then the x's go together. Oh, yeah, I did that backwards, because I'm used to doing y2 minus y1. But it doesn't matter which, just so long as you do them in the same order. So I had the 2's in the front and the 1's in the back. Thanks. Just make those 1's and we'll make those 2's. Yeah, the 2's can go in the front or the 1's can go in the front. It doesn't matter which point goes in the front, just so long as I don't do like 4 minus 2 on top and then negative 1 minus 0 on the bottom. Like I have to go in the same direction. Does that make sense? If I have two parallel lines, the slopes are identical to each other. So if I say the first slope is 2/3, the second slope would also be 2/3. So if I pick a point somewhere and I go up 2 over 3, up 2 over 3, up 2 over 3, up 2 over 3, that will give me my line. So that would be maybe line 1. And then line 2, no matter where I start, it's going to have the same slope, up 2 over 3, up 2 over 3, up 2 over 3. Okay, so right, so all parallel lines will have the same slope. Perpendicular lines are a little different. They're opposite reciprocals. Okay, so if I have two lines that are perpendicular to one another, if the slope of line 1 is perpendicular to the slope of line 3, let's say, I'm going to use the same graph, so line 3, then M1 would be 2/3. The slope of line 3 is going to be negative 3/2. Opposite reciprocal is opposite and upside down. So if one's positive, the other will be negative, and then they'll be flipped. So if I'm doing the perpendicular line, and I pick any point to start with, say here, I'm going to go down 3 and over, whoops, that wasn't 3. 1, 2, 3, and over 2. Down 1, 2, 3, and over 2. 1, 2, 3, and over 2. Then when I graph this line, it'll be perpendicular because the slope is opposite and upside down. I'm going to give you a slope, and then we're going to say, okay, what slope is parallel and what slope is perpendicular, just to kind of practice. Okay, so the first one is 2. Parallel will be 2. Perpendicular is going to be negative 1/2, because a 2 is the same as a 2 over 1. So if you have a whole number and you have to flip it, you get a 1 on top. Okay. If I have my second one is a negative 1/5. Parallel will be negative 1/5, and perpendicular will be, or 5. You can leave the 1 in there if you want. Parallel? Perpendicular? Not too bad? Parallel is the same slope, right? Perpendicular is the opposite and upside down. And neither is anything else. If they're not identical and they're not flipped in opposite, then it's not perpendicular or parallel, it's just intersecting. It could be anything, yeah. Yeah, just any, this is, whenever it's neither, it's any intersection. So parallel is no intersection, perpendicular is an intersection at 90 degrees. Everything else is the neither. So what you want to do on these is you have to find the slopes of line M and line N. Okay, so line M slope, if I call this x1, y1, and x2, y2, I can do whichever one minus the other one as long as I keep them in the right order. So I did 2 minus 1 in this case. So I get negative 6 over negative 2, which gives me a positive 3. Negative divided by negative is a positive, right? And then if I do line N, if I call this one 1s and this one 2s, I'm going to get 1 minus 2 over 6 minus 3, and I'll have negative 1 over 3. I have a positive 3 and a negative 1 over 3, so they're opposite and upside down, so these are perpendicular. Here's the symbol for perpendicular, here's the symbol for parallel. You'll actually have to probably write the word neither, there's no symbol for that. You can put the word. We'll have line M again, lime, not lime, line M. I can do 0 minus 13 over negative 11 minus 14. So I get negative 13 over negative 26. 13 goes into 26 twice. So that's going to be a positive 1/2. Line N, I have negative 5 minus 7 over negative 4 minus negative 3. Don't forget, if you're subtracting a negative, it becomes positive. So I'm going to get negative 12 over negative 1, which is just a positive 12. Sorry, that shouldn't have been 26. That should have been 25. That just changes this. Sorry, bad math. I was trying to make it work. Which just gives me positive 13 over 25 and 12. Absolutely no relationship to each other whatsoever, right? So they're not parallel or perpendicular. Last one. 2 minus 6 over negative 9 minus 3 gives me negative 4 over negative 12. They both divide by 4, so I get 1/3. And line N, 3 minus 4 over 2 minus 5, so I'll get negative 1 over negative 3, which is positive 1/3. So they're parallel. Just on a hypothetical, if you get 2/3 and 3/2, don't get confused and think that's perpendicular. Because with perpendicular, they have to be one positive, one negative, so this would be a neither also. Okay. Because it has to be both opposite and upside down. Okay. So just be careful on that. Tell you to graph a line with a slope of 1/2 through a point. Okay, so first you find the point. So step 1 is graph this. Okay, so I have 2, negative 5. That's my point. Okay, now my slope is 1/2. That means I'm going to go up 1 and over 2 from that point. So I go up 1 over 2. Now I have 2 points. If I want a third one, I can do it one more time, up 1 over 2. And then to graph the line, I just connect my dots. Is that okay? So I'm going to start at negative 3, positive 4. And here my slope is 4, which is 4 over 1, which means I'd go up 4 and over 1. But look what happens. I go 1, 2, 3, I'm out of room. Okay, and I did that on purpose because I wanted to show you what to do in this case. If there's no room, go backwards. Down 4, back 1. So you'd want to go up 4, over 1, but since you can't go up 4, go down 4. But then instead of going to the right 1, you're going to now go backwards to the left. So you go 1, 2, 3, 4, back 1. And you could do another one if you want to. And then you connect them with a line. Not too terrible? I want to graph a line that contains this point but is perpendicular to a line with these 2 points. So step one is to graph these points. Okay. So I have negative 2, negative 3, and then 2, 0. Okay. Step 2 is to draw a line through those. So you'd take a ruler so you could draw a nice prettier line that I'm about to draw, but I'm going to cheat. Okay, so you draw the line. Step 3 is to count the slope. 1, 2, 3. 1, 2, 3, 4. So my slope is 3/4. Okay, of this line. Then determine the new slope. Well, I want perpendicular. So my new slope is going to be -4/3. So far, you guys following me? So that's 4th. 5th would be to graph this point. -3, 0. I'm going to do this in black now. So I've got -3, 0. That's point A. And then 6th is going to be to count the new slope from the point not on the line. So from point A, I'm going to count the new slope. So I'm going to go down 4, 1, 2, 3, 4, and then over 3, 1, 2, 3. And then finally, connect the new dots. So then I'll come in and I'll connect these dots. And I have a perpendicular line. Okay. If I do the same thing for a parallel line, I'm going to graph -6, -2, and 0, -6. And I'm going to connect that. That's my first line. And then I'm going to count the slope. I'm going to go 1, 2, 3, 4. So down 4. 1, 2, 3, 4, 5, 6. I went over 6. So that's -4/6, which is the same thing as -2/3, because I reduced it. The point I want is here, so 0, 1. And I want parallel. So my new slope is the same, because it's parallel. So it's the same slope. So I'll go down 2, 1, 2, and over 3, 1, 2, 3. And then I can connect the dots. No, I can't. If I don't even hit the dots, I can't connect the dots. But you get the idea. Now I've drawn my second line parallel to the first.